The first computer that resembles the machines we use today was invented back in the 19th century. It already seems much earlier than you probably thought, but there was an even older prototype. The Antikythera mechanism was invented by the Greeks over 2,000 years ago. Over a century after its discovery, scientists might have finally solved its mystery. Sponge divers accidentally found the Antikythera mechanism on the bottom of the sea of the Greek island of Antikythera at the very beginning of the 20th century. It was one of the many ancient treasures from the shipwreck of a Greek trading ship that probably set sail around the year 60 before the Common Era. There were marble statues and jewelry, beautiful glass bowls, rich furniture, and one mysterious device. It had a case made of a corroded clump of metal and was the size of a large dictionary. The sponge divers didn't know what to do with it and took this strange item to the National Archaeological Museum in Athens. Months later, the lump broke apart and it turned out that a real architectural gem was hiding inside. It had at least 30 gears, and there were traces of many more that hadn't survived. The mechanism was just sitting there for 50 years before historians finally decided it was worth their attention. The big brains who worked with it thought it was a super complex astronomical calculation machine from over 2,000 years ago. They couldn't believe it could have been made in ancient Greece or anywhere else in the ancient world. The tech behind the gadget was centuries ahead of its time. Over the decades, different scientists have been trying to solve the mysteries of this super advanced device. They've used X-rays, CT scans, and all sorts of fancy tools. They thought it could have been a navigation device, or even some kind of time travel contraption. Some of them even believed it wasn't from our planet. In 2021, a team of scientists presented a computational model that showed how this unique contraption might have worked. According to them, it was like a tiny ancient supercomputer, covered in Greek inscriptions with some astronomical secrets hiding in them. The Greeks probably used it for tracking the positions of the sun, the moon, and lunar phases with a half-silvered ball. The way the moon moves in the sky is really tricky to copy. To do it, whoever created the mechanism used a very clever system with special gears and a slot and pin mechanism. These gears, called epicyclic gears, work together in a complex way. The slot and pin help to make tiny changes in the moon's movement. If you flipped over the mechanism, you'd see some groovy dials, including one with a spiral slot that tracked lunar months. They were used to keep those calendars in check. There was also another dial that predicted solar and lunar eclipses, like some cosmic fortune teller. Depending on which display you were looking at, you could see all of these different functions, so it was pretty much like an ancient tablet. The main theory is that the mechanism was made in a workshop on the island of Rhodes. It could have been a fancy order for a rich customer from northern Greece, and that's how it could have ended on the trading ship. Some people think that the device was the creation of the legendary mathematician and inventor Archimedes himself. But he had lived a couple of centuries before this particular Antikythera mechanism was created. So he could have invented the concept, but couldn't have created this very device. He might have started with a simpler version and then refined it over time, using the latest knowledge of astronomy. Because the Antikythera mechanism is the only physical remnant of many mechanical astronomical displays from the past, we have nothing to compare it with. It might not let its users travel back and forth in time, but it sure could predict astronomical events in the future. The ancient Greeks didn't create it to do work. They were trying to model the skies. It doesn't look like they needed it for navigation, so another theory is that they could use it to create horoscopes. But then again, it was way too complicated for such an entertaining purpose. It sounds more like it was some kind of a philosophical and educational tool. It had in one place all of their knowledge of the universe and how it works that was available at its time. The inscriptions on the mechanism weren't some instructions for experts. They were made for everyone to easily understand them. The latest news about the Antikythera mechanism is that scientists from the University of Glasgow used some special math methods on it. They wanted it to figure out how many holes were in one of its broken rings. They found new proof that one part of the Antikythera mechanism was probably used to keep track of the Greek lunar year. In a new paper they published, the scientists shared that they found that the ring probably had 354 holes. This new research was sort of inspired by a YouTuber who collected data on the mechanism. He was trying to make a copy of the calendar ring and was looking for ways to figure out how many holes it had. To solve this mystery, co-authors of the new study used a special math method called Bayesian analysis. This method uses probability to figure out uncertain things based on incomplete information. They looked at the positions of the holes that were still there and the placement of the 6 surviving pieces of the ring to calculate the likely number of missing holes. Now, they're more sure than ever that the ring had either 354 or 355 holes, not 360 holes, which some earlier studies had suggested. The second co-author of the study used the same techniques that normally analyze the signals from the gravitational wave detectors. These detectors measure tiny ripples in space-time caused by massive events like black holes colliding. The results were really detailed and showed the same number of holes as the mathematical method. The holes were placed with amazing accuracy, with only a tiny average difference of 28 thousandths of a millimeter between each hole. Professors behind the study were really impressed with this, as the ancient Greeks had to measure very accurately and have a very steady hand to punch the holes so precisely. So, it looks like the previous studies that had suggested the gadget used to track the lunar calendar must have been correct. No matter what it really was, the mechanism changed our understanding of how advanced the ancient Greeks were. We knew they had built the Parthenon and the Lighthouse of Alexandria even earlier than they created the device, but this one takes them to a whole new progress level. Some things are still not clear about it, like why it took so long for scientists to catch up and invent something as sophisticated as this ancient marvel. Perhaps there's still some gaps in the historical record. Another question is why we haven't found more of the same unique advanced mechanisms. This could have a practical explanation, as bronze was a precious material back in the day of the mechanism. So, when one contraption stopped working, people probably melted it down for its valuable materials to reuse them. Or maybe there are more ancient computers hiding at the bottom of the ocean and we have yet to discover them. Most researchers have agreed with the results of the new study, but there is one who doesn't. Mechanical engineer Tony Freeth, who is an expert on the ancient computer, believes the conclusion of the study is just wrong. He claims the gadget already has one lunar calendar that is more precise than this one. Looks like, although we are one step closer to solving the Antikythera mechanism mystery, the hunt for the truth is still far from being over.
Most people know that pyramids were built as grand tombs for the pharaohs, designed to ensure they had a smooth journey to the afterlife. The Great Pyramid of Giza, for instance, was constructed for the pharaoh Khufu. But what most people don't know is that this whole pyramid building trend started right here with the step pyramid of Djoser about 4,700 years ago. This massive structure was built for Pharaoh Djoser, a ruler from Egypt's 3rd dynasty. It rises 7 layers high above the ground and stands about 200 feet tall. We think of it today as a phenomenal architectural project, but for ancient Egyptians, the step pyramid of Djoser turned out to be more like a massive experiment, a trial run, if you will, to perfect their building skills before they moved on to even more ambitious pyramids. Reaching new heights is super exciting, but the real mystery is what is going on below the ground. In this pyramid's underground labyrinth, there is a network of tunnels stretching about 3.5 miles long, and some researchers believe these tunnels might have been part of a sophisticated water system that could completely change what we think about pyramid construction. Let's talk about this massive complex located in Saqqara. Surrounding the pyramid, there's what's known as a dry moat, a continuous trench that is up to 164 feet wide and almost 2 miles long. It forms a sort of rectangular shape around the pyramid. This trench has an average depth of about 65 feet. Now, if you were to add up all the earth and rock they dug out to create this moat, it would be about 10 times the volume of the step pyramid itself. For the longest time, people just assumed this trench was nothing more than a huge quarry, a place where they dug up stone and clay to build the step pyramid. Makes sense, right? But when you take a closer look, it doesn't add up. The trench is too narrow and deep to be practical for mining, and its layout doesn't match anything we know about ancient Egyptian quarrying methods. Plus, some sections of the trench are actually covered with a rocky ceiling, which would have made it nearly impossible to use as a quarry. Another theory suggests that the dry moat had some kind of spiritual significance. Maybe it was a sacred place, where souls of nobles gathered to serve the late king in the afterlife. There are even niches in the walls that work as a hint at this spiritual function. But most researchers believe that this purpose likely developed much later, long after the complex was built for Djoser. So, what was the moat really designed for? In 2020, a researcher came up with a pretty intriguing idea. It is possible that this trench was actually designed to collect and manage water, especially after heavy rainfalls. Now, that makes sense when you consider the location. The moat sits in an area that could easily have been flooded by runoff water from nearby plains. This could also explain why the trench wasn't used for new graves until much later when the climate became drier and less prone to flooding. The story becomes even more intriguing, as this trench appears to be part of a larger, more complex hydraulic system within the Djoser complex. It is like the trench has several compartments, carefully carved out of the rock and connected by tunnels. These compartments likely served as a part of a water treatment system, where water would flow from one compartment to the next, getting cleaner as it moved along. Now, here is where things start to tie into the pyramid itself. The Djoser complex has a series of underground shafts, and some researchers think that water from the moat's deep trench might have been used to power a hydraulic lift system, and this giant water-powered elevator could have been used to raise the heavy stones needed to build the pyramid. It worked like a volcano, but instead of lava, water did the heavy lifting. Imagine a big deep hole in the ground at the center of the pyramid site. Inside this hole, there was a huge wooden platform, kind of like a giant raft that could move up and down. When the workers wanted to lift a heavy stone, they would fill the hole with water. As the water rose, the wooden platform started to float up, carrying the stone with it, almost like a giant water-powered elevator. When the stone reached the right height, the workers slid it off the platform and onto the pyramid. The idea is that water from the deep trench, after being cleaned and filtered, would flow into these shafts. A massive float, possibly made of wood, would then rise as the water filled the shaft, lifting the stones up to where they were needed for construction. Once the stone was in place, they'd let the water out, lowering the platform back down to the bottom, ready to lift the next stone. This fancy hydraulic lift system could have been a game changer, making the whole building process a lot faster and more efficient without using a lot of workforce. It is like the ancient Egyptians were already embracing the whole idea of work smarter, not harder. But of course, not everyone is on board with this theory. Some experts argue that the area where the step pyramid of Djoser was built couldn't have held enough water from occasional rains to maintain such a fancy hydraulic system. The main theory suggests that, in the past, there might have been some kind of lake nearby that would have filled up after a period of rain, and this lake could have supplied water to the complex's hydraulic system. But there is no mention of such a lake in any ancient Egyptian writings, so it might be more of a what-if situation than a reality. And then there's the issue of the hard work itself. Remember when I said this method could have allowed the ancient builders to raise stones with far less effort? Well, that might not be entirely true. According to some experts, just building this hydraulic device would have required a lot more heavy work than simply moving the stone blocks using good old-fashioned manpower. And let's not forget, The step pyramid of Djoser is like a baby pyramid compared to those that came later. The stones used for Djoser's pyramid weighed, on average, about 660 pounds each, which is nothing compared to the more than 2.5-ton blocks used later for the pyramid of Chephren. If this cool water lift theory gets completely ruled out, we still need to explain how this pyramid was built in the first place. To answer that, we need to rewind a bit and talk about the original plans. See, before Djoser's tomb became a pyramid, the idea was to construct a simple mastaba. This type of tomb was pretty common in earlier periods, a flat-roofed, rectangular structure with sloping sides. But after the original mastaba was finished, they decided to expand it a bit by adding more layers on top. And then they added even more layers, until the construction reached 6 distinctive steps, each one smaller than the previous. And they probably did all this by raising those heavy stones using ramps, not a water-powered elevator. There is still so much we don't know about the step pyramid of Djoser. More research is definitely needed to fully understand how this system worked, or if it even existed at all. But the idea of using water to help build the pyramid adds a whole new layer to our understanding of ancient Egyptian engineering. It's a powerful reminder of just how clever and resourceful those builders were, using the natural landscape and the power of water to create one of the most iconic monuments in history.
Egyptologists have been digging around every inch of the Great Pyramid for ages. Yet somehow, they overlooked this stunning pink granite bathtub buried a few miles next to it. And here's the deal. This mysterious oval tube lying next to the Khufu pyramid for years may provide evidence that the Egyptians built the pyramids not only for monumental purposes, but also to generate electricity, experimenting with it long before Alessandro Volta and Thomas Edison. The Giza Plateau is famous for its 3 pyramids, Khufu, Khafre, and Menkaure. But there are also 2 smaller foundations next to them, the unfinished North Pyramid of Zayet el Aryan and the Layer Pyramid. Some researchers say these buildings were never finished, while others think they were destroyed for more mysterious reasons. One of these reasons might have to do with the original usage of the Giza pyramids, the idea that they were used as an electricity generator. To connect these dots, we need to go back to the beginning of the 20th century. That's when an Italian architect and Egyptologist named Alessandro Barsanti decided to examine the Zayet el Aryan pyramid. Near the site, he noticed something unusual: scattered granite fragments. To a casual passerby, these might have seemed insignificant, but Barsanti recognized the signs. You see, ancient Egyptians often used sites to prepare stones before transporting them to their final destinations. The fact that there was granite on the ground intrigued him. Granite was a more expensive material than the limestone typically used for pyramids, which suggested that it might have been intended for an important and possibly hidden structure. At a depth of 68 feet, they encountered a huge pink granite block. He kept going with the excavations, and they revealed ancient inscriptions carved into the stones. They sent the drawing to experts, but no one could decipher what they meant. Were they instruction sets to something? That's when Barsanti made his biggest discovery. He found an oval-shaped vat carved from pink granite and polished to a mirror-like finish. The thing is, the vat had been carefully sealed. When they opened it, they found a thin black residue along the walls. I'm thinking something in the lines of a black oily substance. This discovery raised many questions for him. It didn't make sense to him that ancient Egyptians would go above and beyond to seal and protect this strange vat. By 1911, Barsanti had to abandon his effort to figure out what was the deal with that mysterious pit. But his findings intrigued researchers all over the world, and they've got their own opinions about it. One of these modern theories suggests that the other pyramids could have been used as a part of a bigger whole. It suggests that the Khufu pyramid was actually used as a water pump designed to irrigate the desert area. Apparently, the pyramid's internal chambers would function as a hydraulic system. In the 1990s, an engineer took this theory seriously and studied the pyramid's subterranean chamber. Surprisingly, he found actual signs of water damage. Apparently, the pyramid generated powerful compression waves, aka pulses, that could create electricity. This raised an important question. Could the ancient Egyptians have used the pyramids as a generator in order to produce electricity? On paper, that was proven to be possible, but hey, agreeing on the original use of the pyramids is probably one of the most difficult things in the world. So, we're still not 100% sure about this. Apart from that, Egypt is a playground for important discoveries regarding humanity's past. I mean, scientists have just discovered what looks like a cosmic command center, similar to that room from the Doctor Strange movies. They discovered an L-shaped astronomical observatory, measuring around 9,000 square feet, dating back to the 6th century BCE. Definitely the first and largest of its kind from that era. The mud brick structure housed tools used for calculating dates related to ancient Egyptian rites, royal coronations, and agricultural plans. This observatory is located in the archaeological site known as the Temple of Futo, just 50 miles east of Alexandria. It's pretty impressive. The structure was designed so that you'd get inside the room through an east-facing entrance. This way, you'd get to see the sunrise. Once inside, you'd find a pretty huge shadow clock, used to tell time by tracking the movement of shadows inside the room. This variant of a sundial clock was nearly 16 feet long. That was quite an exciting discovery. Another interesting one was that scientists and Egyptologists have discovered the first ever pregnant mummy. Now, even if we know quite a lot about mummification processes, we keep making discoveries that open new doors into the lives of ancient Egyptians. It took so long for someone to find out this mummy was expecting at the time she was embalmed because she was placed in a male's coffin. More specifically, a male priest. Historians say that during the 19th century, a lot of traders mixed coffins up in order to sell them. Yes, that means they opened them and switched mummies to please their buyers. It was a complete surprise because they were hoping to study more about ancient health issues when they opened this coffin up. But they had another special research on their hands: prenatal practices in ancient Egypt. This mummified woman, who lived about 2,000 years ago, was from 20 to 30 years old when she passed away. She was found in Thebes, and her remains were incredibly well preserved. You see, mummification recipes varied across Egypt. In this woman's case, researchers could tell she was a member of the high society since she was buried with special amulets. But since mummification methodologies differed so much between cities and time periods, they still have to dig further to understand why she was embalmed along with her baby. Speaking of mummies, scientists were digging up a final resting place in Saqqara, also in Egypt, and they unearthed two embalming workshops. One was for humans and the other for sacred animals. Apparently, the workshops date back to about 2,400 years ago. They were equipped with stone beds, clay pots, and ritual vessels. Everything you needed to mummify. But that's not all. Archaeologists also stumbled upon cheese stored in jars behind tombs that were over 3,000 years old. Yep, cheese. This shows that the ancient Egyptians were pretty savvy when it came to preserving food, too. They knew how to store stuff for the long haul, not just the mummies. It really shows how they applied their preservation skills to both food and bodies, giving us a glimpse into their impressive technological know-how. Scientists have also found one of Egypt's oldest complete mummies, and to their surprise, it was completely covered in gold. You see, Egyptian mummies covered in gold are already a rare thing, but they weren't expecting it to be the oldest one ever found. The mummy was quite well preserved, and they could identify that it was the remains of a wealthy man called Hekashepes. Many symbols show that he was important and wealthy, like the band he wore on his head and the bracelet on his chest. He was also dressed in a tunic wrapped with a belt, which was a way to preserve the good appearance of a person after they passed away. To reveal it, they had to open the final resting place with mortar. Basically, it was like they were opening a time machine, just as the ancient Egyptians did 4,300 years ago. If you think about it, it's almost like entering a time capsule. Enough about mummies. Scientists also found something very exciting hovering above the pyramids. They had to use a fancy top-notch radar known as LARID, aka Low Altitude Long Range Ionospheric Radar, which can see these invisible waves far away into the sky. LARID helped them discover giant plasma bubbles floating in the air above the pyramids. These bubbles are called plasma bubbles, and they wreak havoc on modern technologies. I mean, they can disrupt GPS and phone signals for hundreds of kilometers in diameter from where they're located. These bubbles are massive, sometimes as big as cities, and they're caused by the sudden depletion of charged particles in the ionosphere. So, instead of spreading out evenly throughout the ionosphere, they stick together in this wave-like form. This was a pretty important discovery because it can help scientists understand how to prevent these waves from messing with our technology. X-rays are a type of invisible radiation that can pass through our bodies and objects. They're very important in the field of medicine because they allow doctors to see inside our bodies without having to perform surgery. Now, let's dive into how X-rays work. They're a kind of electromagnetic radiation, just like light or radio waves. However, they have much higher energy than light, which makes them able to go through objects that light cannot. Imagine you have a powerful flashlight. If you try to shine it through a wall, the light won't go through because the wall is too thick. But these rays have enough energy to go through walls and even our bodies. The discovery of X-rays happened by accident in the late 19th century. A scientist was experimenting with cathode rays, which are a type of radiation. He was working in his lab and noticed that a nearby fluorescent screen started to glow, even though it was not directly exposed to the cathode rays. He realized that something invisible was causing the fluorescence, and he named it X-ray, because X is the mathematical symbol for something unknown. He continued experimenting with such rays and discovered that they could pass through many objects, like flesh and bones, but not through denser materials like metal. He also found that X-rays could create images on photographic plates, just like a camera takes pictures. The way this works is quite fascinating. Imagine you're standing in front of a bright light and you hold your hand in front of your face. Your hand blocks the light and you can't see through it. But if you place a sheet of tissue paper in front of your hand, some light will pass through, and you'll be able to see the outline of your hand. X-rays work in a similar way. When a doctor wants to take an X-ray of a part of your body, they will ask you to stand or lie down next to a machine. This device has a special plate that can capture the image. Let's say the doctor wants to further examine your arm. They will place the X-ray plate on one side of your arm and the machine on the other side. Then, the machine will produce a controlled burst of X-rays that pass through your arm. Remember how we talked about the tissue paper allowing some light to pass through? Well, in this case, some of those X-rays will go through your arm, while others will be absorbed or blocked by the denser parts of your body, like bones. The plate captures the X-rays that pass through your arm, and it creates an image. This image shows the bones and other structures inside your body, allowing the doctor to see if there are any problems or injuries. Now, you might be wondering why X-rays can pass through some things but not others. It has to do with the density and composition of the objects. Denser materials like bones absorb more X-rays, so they appear white in the image. So when you look at the result, you'll see your bones as white shapes. Other tissues like muscles and organs are less dense and allow some of those rays to pass through, so they appear as gray shadows. What if I told you there's a whole new way you can peek inside objects, but without using X-rays? I'm not talking about magic powers. Take a comfortable seat while I explain what muography is. This fascinating scientific technique allows us to see inside objects and even beneath the Earth's surface using a special type of particle called a muon. These elementary particles are very similar to electrons, but they're much heavier. They are created high up in the Earth's atmosphere when cosmic rays, which are particles coming from space, collide with the air molecules. Now, muons are special because they can pierce through different materials. They can pass through rock, soil, and even buildings. Scientists realized this potential back in the 1950s when they were studying cosmic rays and noticed that some of the particles could pass through thick materials. The first muography experiments took place in the 60s. Specialists discovered that muons can be detected using special devices called muon detectors. These detectors are usually placed underground or in specially designed laboratories to shield them from other particles and background radiation. Now let's dive into how muography actually works. Imagine you have a large object, like a pyramid, a mountain, or even an ancient statue, and you want to see what's inside without damaging it. First, detectors are positioned around the object or in the area you want to examine. These detectors are sensitive to muons and can track their paths. When such a particle passes through a detector, it leaves a trace, like footprints in the sand. By collecting data from multiple detectors, scientists can reconstruct the paths. Here's where things get really cool. The Earth's atmosphere acts like a natural filter for muons. It turns out that the more massive an object is, the more particles it will block. So, if you have a large, dense object like a mountain, fewer muons will pass through it compared to a smaller, less dense object, like an empty box. This difference in the number of particles that reach the detectors can give us clues about what's inside the objects. Scientists use computer algorithms and mathematical techniques to analyze the data and create images. These images represent the density distribution of the object being studied. It's like creating a map that shows where the densest areas are and where there's gaps inside the object. The concept of muography is similar to using shadows to understand the shape and size of an object. Imagine you're standing in front of a bright light and you place your hand between the light source and a wall. You'll see a shadow of your hand on the wall. Based on the shape and size of the shadow, you can get an idea of what your hand looks like, even though you can't see it directly. This technique has been used to study various objects and structures. For example, scientists have used it to explore the inside of volcanoes and pyramids, and even to investigate the structure of mountains and the Earth's crust. With the help of this amazing technique, scientists have now uncovered new information about the Great Pyramid of Giza. They discovered something that had eluded tomb raiders for centuries. They found a hidden chamber. And guess what they named it? The Big Void. Yeah, I know, not the most creative name. They even used 3 different muon detection techniques just to be super sure that it was indeed a big, mysterious void inside the grandest pyramid of them all. Once news got out about this mind-boggling discovery, Egyptian authorities couldn't resist the temptation to explore further. So, they brought in an endoscope camera to confirm the existence of this epic void. So, they inserted a camera through one of the openings underneath the entrance, and voila! It revealed a corridor. More so, the corridor had a chevron ceiling. I can't help but imagine the ancient Egyptians using it as a cool dance floor. Another team of scientists decided to take another shot at scanning this newfound void. According to them, the Great Pyramid of Giza is a pioneer in the pyramid game. It used a technique called chevron to cover internal structures and keep them from collapsing. Now, why did the ancient Egyptians build this corridor and the grand void it leads to? One theory suggests that the corridor was built to relieve pressure inside the pyramid. Another theory says that the void could be a result of the pyramid's construction process. It could have been an internal ramp used to move roof blocks into position, and then it was left there or filled loosely with rubble. According to other enthusiastic explorers, there might be another burial chamber waiting to be discovered. They believed that the pyramids were built with a dash of randomness in the construction process. As the builders worked their magic, they realized that some chambers wouldn't be able to handle the weight of a majestic sarcophagus. So they made adjustments on the fly, creating new plans as they went along. He let down his mother's dreams and never became a farmer like she wanted him to. His relations with other people were so complicated that he was alone his entire life. He was interested in alchemy and became one of the most famous scientists of all time. Yes, I'm talking about Isaac Newton, the English physicist and mathematician who shaped modern physics as we know it. Newton was born in a small settlement of Woolsthorpe in 1643. He never got to meet his father, also named Isaac Newton, who passed away before his son was born. Around the same time, over in Florence, Galileo Galilei, another brilliant scientist, took his last breath. Little did Newton know, he would later take up Galileo's ideas and make them legendary. Back in his very first days, little Isaac had to struggle to survive as he came into this world prematurely. He was so small that he could fit inside a big mug. His mom remarried soon after he was born, and his stepdad took her to another village to raise his own family. Newton ended up at his grandma's, separated from his mom for a good 9 years. The boy would mostly spend time alone. This left an impact on his entire life. Years later, when he was making a journal of his wrongs, he even confessed to some fiery thoughts about his stepdad, like wanting to burn down the house. On the bright side, he became interested in books on mechanics and technology. He created a detailed system of sundials that were super accurate at telling time. His uncle and his school headmaster saw his intellectual potential. Years later, when his mother became a widow again and wanted Isaac to run the family property, the headmaster and the uncle managed to convince her it wasn't the best idea. Instead of tending to cows and crops, the future science star would curl up under a tree with a good book. His mother finally gave up, and the young man went back to grammar school. At 18, he was ready to enroll at Trinity College, Cambridge. To pay for his education, Newton was doing a sort of a work and study program, waiting on tables and taking care of other students' rooms. At the time he arrived there, the world was witnessing groundbreaking discoveries, the new concepts of nature and the universe. But, like at most universities, Newton was taught the old Aristotelian philosophy. He felt like the standard curriculum wasn't enough for him, and he spent his spare time reading modern philosophers and studying new mathematics. He put down his findings in a notebook entitled Certain Philosophical Questions. And although he graduated without honors, it was the starting point for his brilliant scientific career. In 1665, the plague hit, shutting down the whole university. Newton was stuck at home for the next couple of years, and his brain went into overdrive. He was cooking up groundbreaking ideas from the comfort of his own home and laid the groundwork for what we now call calculus. And he didn't stop there. The genius took a previous insight he had and expanded it into an essay called Of Colors. It contained loads of mind-bending ideas that later found their way into his famous work called Optics, uncovering the secrets of light and colors. He denied that light was simple and homogeneous. He found it to be a really complex phenomenon. He also stated that light is separated into different colors by a prism. And it was during this shutdown that the famous Newton versus an apple episode happened. There's no proof that the fruit actually dropped on the scientist's head. But he did spend time in the orchard, and watching an apple drop made him wonder why apples always fall straight to the ground, not sideways or upwards. Now that might not sound like much, but that little tidbit became the cornerstone of the law of universal gravitation. The world had no clue about these mind-blowing discoveries happening in Newton's brain, though. Once the shutdown was over, the bright mind got a minor fellowship at Trinity College. He started teaching there when he was 26. Newton was still not exactly the communicative type, had few close friends, and often forgot to eat because all his thoughts were focused on work. He wasn't the student's favorite lecturer and is said to have taught an empty class when no one showed up. It didn't bother the scientist, though. He always preferred doing his own research to teaching others. At that stage of his career, Newton wrote a treatise which he shared with friend and mentor Isaac Barrow. This was the first time when the mathematics community noticed and recognized Newton's work. Soon after, Barrow resigned from Cambridge and left Newton in charge of the chair. His findings and works became famous in the world thanks to the Royal Society of London. They recognized him and got interested in Newton when they found out about his invention, the first known successful reflecting telescope. Previous telescopes used lenses to focus light, and the image got distorted. Newton's invention used a mirror, which made the images much clearer. The scientist couldn't stand any criticism and never forgave people who dared to speak badly about his work. At some point, the criticism of others made him spend 6 years of his life in complete solitude. His probably biggest intellectual rival was scientist and philosopher Gottfried Leibniz. The two couldn't decide which of them had invented calculus. Newton had developed his version back in the 1660s, but he was so secretive that he decided not to share it with the world. A decade later, Leibniz formulated his own version of calculus and went on to publish it another year later. Newton accused Leibniz of straight-up plagiarizing his unpublished writings. Leibniz claimed that he had independently reached his results and suggested that Newton was actually the one stealing from his published work. Leibniz, in an attempt to defend himself, appealed to the Royal Society, the prestigious scientific organization. And guess who was the president of the society? You guessed it, Newton himself. He stacked the committee that was to make the decision with his own supporters and even wrote the committee's report himself. In the end, Newton's version of events was the one publicly credited, but Leibniz's system of calculus is the one commonly used today. When Isaac Newton passed away, he left behind no will and a massive pile of work. Around 10 million words, which is enough to fill a whopping 150 novel-length books. These correspondences, notes, and manuscripts contained page after page of mind-blowing scientific and mathematical brilliance. And they also revealed another side of Newton that his family desperately tried to keep under wraps. Alongside his groundbreaking scientific work, Newton was knee-deep into alchemy and theology. The man was determined to decode divine prophecies. Newton didn't have any offspring, so the husband of his half-niece became his heir. He didn't want the world to discover that side of the scientific star. For centuries, they kept Newton's work hidden from prying eyes. Only in the late 1800s, the papers finally made their way to Cambridge. They were chaotic and unsorted, a total nightmare. The university assigned John Couch Adams, the co-discoverer of Neptune, and George Stokes, another brilliant physicist, to sort Newton's works. The scientists decided to procrastinate for 16 years. But when they finally faced the daunting task of going through the papers, they were in for a shock. Imagine being confronted with the works of this scientific hero, only to discover that he was writing about alchemy and secular matters. Another thing scientists didn't expect to see was 6 or 7 copies of the same thing. Newton had a habit of writing tons of unfinished treatises, and he would go over the same ideas again and again. Adams and Stokes must have been disappointed, and they even joked that the scientist must have loved his own handwriting more than he loved the things he wrote about. We still don't know why there wasn't a complete, edited collection of Newton's papers. All the other big-shot scientists from that era had their works published ages ago. But Newton's work is like a bizarre gap in the history books.
There are probably 36 other civilizations hanging out in the Milky Way, and over 170 billion galaxies, give or take, in the observable universe. Conditions for life are all over space. So, where is everybody? Nuclear physicist Enrico Fermi came up with this exact same question during a lunch break with his colleagues in 1950, leading to one of the most unsettling paradoxes in the universe. Even though there's a huge probability of extraterrestrial civilizations existing, we still haven't found any clear evidence of them. One possible explanation comes from the zoo hypothesis. It suggests that advanced extraterrestrial societies exist and know exactly who we are and where we are, but intentionally choose to stay hidden. They're just observing human quirky behaviors, as if we're in some kind of a cosmic wildlife park. But their intentions could be much darker. If you're a Star Trek fan, you probably remember the main rule for Federation members. Starfleet officers shouldn't contact species that are not advanced to avoid messing with their development, even if it means risking their own lives. Now, even though it's fiction, this rule perfectly captures what the zoo hypothesis is all about. Beings from other corners of the universe see our planet as a cosmic zoo with one-way bars. They can watch us brushing our teeth in the morning or walking our dog, but we can't catch a glimpse of them. In this theory, non-terrestrial life forms deliberately keep their distance from us, sticking to a hands-off policy agreement in the vast cosmic neighborhood. It's like those super smart beings agreed that we needed to have the freedom to shape our own future and destiny, following our own path of development without external contamination. The idea is that these super advanced civilizations could be like, 500 million years ahead of us, which would explain why we haven't seen any signs of them. And maybe it's better this way, as humans could eventually be destroyed or even assimilated by this new cosmic power, Independence Day style. As much as things like going to an art museum might be interesting to us, extraterrestrials probably wouldn't be too thrilled watching us stare at the Mona Lisa painting for hours. Interplanetary cultures might be more into buying tickets to quietly observe how we're developing new technologies, such as ultra-modern satellites. According to the zoo theory, they can't reach out to us until we hit a certain level of development, so improving our technology and wisdom could be the only way to show them that we're mature enough and don't need their spaceship parenting anymore. There are a couple of reasons why it's hard to buy into the zoo hypothesis. Extraterrestrials might not visit or reach out because we're not all that advanced. But it is tough to explain why they keep ignoring all our attempts to communicate. Even if the zookeepers try their best not to interfere with animals' lives and behaviors. I bet they couldn't just ignore a bear speaking in loud and clear English about its desire to communicate. So that's pretty much why humans keep trying and trying to provoke some reaction from inhabitants of other planets using radio signals. In 2017, in a valley 8 miles southeast of the Norwegian city of Tromsø, a radar antenna transmitted some specially composed electronic music to potential intergalactic listeners. The target audience was in GJ273, also known as Lytton Star. It's a runty red dwarf located 12 light-years from our solar system. Since radio waves travel at the speed of light, we'll have to wait more than 2 decades before looking for a reply. But the main problem with radio waves is that we're kind of in the dark about where to look, and civilizations might be as far as 17,000 light-years away. Plus, we don't know which radio frequency extraterrestrials use to chat. Now here on Earth, we use the radio spectrum to send signals into the universe, assuming that what works for us might be a common method for other civilizations. But in fact, it could be considered a somewhat old-school technique for other beings. That's why current projects are now looking for technosignatures, which are signs of technological activity from extraterrestrials, like city lights, solar panels, megastructures, or artificial satellites. Another potential clue is to study the atmospheres of planets orbiting nearby stars, as an advanced civilization might be altering its atmosphere with different gases, making it detectable. Despite decades of observations, there is still no definitive evidence that advanced extraterrestrial civilizations are out there. But that doesn't mean they don't exist. Even by expanding search fields, We're talking about odds much slimmer than hitting the jackpot, with a roughly 1 in 3 billion chance of finding an advanced civilization within a given distance from Earth. Maybe space creatures are responding to our communication attempts, but in a way that we can't understand. The universe has been around for more than 13 billion years, while humans showed up just 200,000 years ago. And this is about 0.01% of the universe's age. It's like we're still learning to talk, while other super smart beings might be sending us messages that are all lost in translation. We keep waiting for a giant UFO to land on Earth and for green ETs with huge eyes to come out of it. But we forget that our intergalactic neighbors could be more interesting in building nanotechnologies to watch over us. They could also be trying to communicate using neutrinos, which are subatomic particles with an extremely small mass that could effortlessly pass through our planet without being detected by our current technological devices. Now, the zoo hypothesis has another issue. It is pretty tough to believe that, with all these civilizations supposedly hanging out in the universe, they would all decide not to reach out to humans. For this to happen, there would have to be a great sense of structure, with a higher intelligence working as the head of the universe, giving them direct orders and clear rules to keep us isolated. But we're talking about billions of possibilities for life, right? More civilizations mean that there are more chances of a violation of this no-contact rule. So, most likely, at least one independent planet would be just as desperate to find life in the universe as we are. Some scientists also believe that if such advanced life had substantially colonized Earth and many other planets, we would know it by now. The zoo hypothesis has two other variations that are even more frightening. In the laboratory hypothesis, nobody contacts us because humankind is actually being subjected to experiments, and Earth is essentially a giant science lab. Otherworldly creatures could be analyzing human responses to various survival challenges, such as tsunamis or massive earthquakes. In this case, the no-contact agreement between all other space groups would make a bit more sense, since it's in the name of scientific research for the greater good, at least for them. The planetarium hypothesis, proposed in 2001, suggests that we are living in an artificial universe, in some kind of virtual reality designed to give us the illusion that the universe is empty when it's not. But no possible generator could test this hypothesis. Besides the zoo, the laboratory, and the planetarium theories, there is another possible answer to the Fermi paradox. Nobody contacts us because humans are completely alone in the universe. This is known as the rare Earth hypothesis, and it emphasizes how Earth occupies an incredibly unique position. No other planet could bring life to the universe that could be more than just bacteria. We may consider ourselves pretty lucky, as even a small change in any of Earth's orbital parameters, like the distance from the Earth to the Sun or the rate of rotation, could make conditions too extreme for people or life in general. But again, it's hard to think that we are alone in this vast universe. So, we're back to the paradox. Where is everybody? We still can't find the source of the mysterious signal we've been receiving since 2018. We receive it every 22 minutes, and nothing can explain this. Some scientists even believe it could be coming from another civilization we haven't met yet. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that, yes, and these signals aren't anything new. They've been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. While that idea may sound exciting, we need to be careful about jumping to conclusions. First, we don't have solid proof for that. Before any concrete evidence, it's just speculation. And also, there are other more plausible explanations. Most likely it comes from a natural phenomenon, and there are a couple of theories for that. The first one is the pulsar theory. Imagine a huge star in space much bigger than our Sun. Sometimes these big stars finish their life journeys in a spectacular event called a supernova. When this happens, the star's core collapses, becoming super compact, as if you're squeezing all the stuff from that star into a tiny space. That tiny, super-dense core is called a neutron star. Some of these neutron stars are extra special. We call them pulsars. They get their name because they seem to pulse with energy, like a space lighthouse. These pulsars have incredibly strong magnetic fields, much stronger than what you'd find on Earth. They're like enormous magnets in space. Because of this, they shoot out beams of energy. They're also spinning super fast, so these beams of energy seem to pulse on and off as they spin around. Now, the strange signal we detected seems to have similarities with pulsars, but not quite. Pulsars usually have a predictable lifespan and slow down over time, eventually stopping their radio signals. In contrast, our mysterious signal is quite persistent and is blinking beyond what's expected for pulsars. So, maybe it's not a typical pulsar, or not a pulsar at all. There's also a magnetar theory. Now, a magnetar is another type of neutron star. They're like supercharged versions of pulsars, with even stronger magnetic fields and slightly longer pulsating periods. Maybe this is what causes our signal's intense persistence. However, when we plotted the data, we also realized the signal didn't match the magnetar's vibes either. Magnetars not only send out radio waves, but also powerful X-rays because they're so energetic. But the signal we received was only sending out radio waves. So we figured it's not a pulsar and not a magnetar. The signal's behavior is very strange and suggests an unnatural source. This means there might be something in the universe that scientists haven't fully explored yet. And there is a space object that we don't know much about. The final theory is the so-called dwarf pulsar. Sounds a little dopey to me. Couldn't help myself. Now, a dwarf pulsar is like a star that blinks with light flashes, similar to pulsars, but it takes longer for each blink. Usually, white dwarfs are the leftovers from smaller stars. They don't blink because their magnetic field isn't as strong as pulsars. But when a white dwarf becomes pretty hefty, almost the mass of our Sun, it gets super dense and starts pulsating with a strong magnetic field, just like pulsars. They have a cool quirk. White dwarfs are made of electrons, not neutrons like pulsars. When these charged electrons start dancing with the magnetic field, they shoot out periodic light flashes, which happen every 100 to 1,000 seconds. As you remember, our signal has a period of 22 minutes, 1,320 seconds. A bit longer than the usual white dwarf pulsars, but it's much closer to the truth. So far, this sounds like the most plausible explanation. But even this theory isn't fully confirmed yet. This just shows how much there is in the universe that we're still figuring out. For example, fast radio bursts, another mysterious type of signal we've been detecting. They're like quick, intense bursts of energy in the form of radio waves. They have a ton of energy. FRBs are so powerful that sometimes they can be brighter than entire galaxies. Now, imagine this. They release as much energy in a few milliseconds as our Sun does in 3 whole days. Wow! These bursts happen all over the sky with huge frequencies, although some have been detected with lower frequencies. Every day, we catch around 10,000 random FRBs in the sky. Some of them repeat, but most happen once and disappear forever. Unfortunately, most of them only last for a fraction of a second, and by the time their energy reaches us, it's 1,000 times weaker than a mobile phone signal from the moon. This is why, despite their brightness, there's still a lot we don't understand about them. We're still trying to figure out what causes these FRBs. They could be coming from different sources, like already mentioned magnetars, colliding stars, or even merging galaxies or white dwarfs. As these bursts travel through space, they pick up information about the cosmic environments they pass through, like interstellar gas clouds. It's very unlikely that FRBs are some messages from extraterrestrial beings, though. Not only because there are thousands of them every day all across the sky, but also because we know that the sources of these bursts must be incredibly energetic themselves. Our neighbors would have to have equipment stronger than entire galaxies for that. But the bottom line is, while all these signals are fascinating, there's still a ton to learn about them.
From where we stand, the Sun seems so calm and peaceful. But like humans, and basically the whole living world, the Sun has its own phases when it's more or less active. It's just that the consequences are way bigger and more chaotic when the Sun becomes hyperactive. Let's zoom in to see what's happening up there. So one of the ways we measure the activity of our star is by counting sunspots on its surface. Sunspots are dark patches that form when the Sun's magnetic field gets all tangled up. It's simple. The more sunspots, the more active our Sun is. And it seems the Sun has been partying like crazy recently. The number of sunspots scientists have seen is the highest for nearly 21 years. In June, 163 sunspots appeared on the Sun's surface. The last time we had so many dark patches across the Sun was in September 2002, when there were 187 of them. Uh-oh. It seems this chaotic party is getting closer to its peak. And that's something we call solar maximum. How does all this even happen? The Sun's magnetic field is strong and organized at some point. But as we said, sometimes comes the time when it kinda ends up tangled, sort of like a ball of rubber bands that are wound together very tightly. This also means plasma is rising from the surface, forming loops, and causing a mess in the shape of solar flares and something we call coronal mass ejections, CME. That's when plasma in the Sun's upper atmosphere, called the corona, goes crazy and bursts really strong. Then at some point, this ball snaps and completely flips and turns the South Pole into the North Pole and vice versa. All this happens every 11 years or so So when the sun comes into this phase when it becomes very active, it shoots out hot blobs of plasma, gets big dark spots as large as planets, and releases powerful eruptions of energy and radiation. Something fascinating happens when the sun becomes more active. A thing called plasma waterfall or polar crown prominence, PCP. It's like a mini eruption that starts on the sun, and it seems like it tries to get away, but then the sun's magnetic field pulls it back before it can escape into space. And this plasma waterfall's really spectacular. It goes up to 62,000 miles above the surface. It's like you stack 8 Earths on top of each other. Then there's something called a polar vortex. It's like a gigantic halo of plasma that rotates around the sun's north pole really fast. This vortex happens when a large tentacle of plasma snaps apart and falls back toward the surface, similar to how a plasma waterfall forms. Scientists don't know why this plasma stays above the sun's surface for so long. And one of the cool examples of CMEs was a giant one in the shape of a butterfly in March this year. It got such an unusual shape because it exploded on the side of the sun we couldn't see, so it was impossible to fully measure how strong it was. Fortunately, that one didn't explode in our direction, but it might have hit Mercury a little bit. And it's possible it knocked off some dust and gas since Mercury has a weak magnetic field. All this sounds cool in theory, but it's not such good news for us. Because of all this, we might experience more intense solar storms that can, again, lead to geomagnetic storms on Earth. And these don't just sound alarming, they indeed are. They create chaos and disrupt the magnetic field of our planet. Geomagnetic storms can create beautiful northern lights, true. But we'd all rather enjoy such beauties as the aurora borealis in regular conditions, or just watch a good old sunset above the ocean. It's not that every solar storm will necessarily hit Earth, even if there are more of them. To reach our planet, they must be pointed in the right direction at the right moment. But if that happens, the storm can ionize the upper atmosphere and bye-bye our communications. It can cause temporary blackouts for systems such as GPS and radio. It isn't necessarily a big problem on its own, but it can be very dangerous if it happens at the wrong time, like during a tsunami or an earthquake. The storms can also damage electrical infrastructure, like rail lines and power grids. If you're on a plane at that time, you might be exposed to higher levels of radiation. It's still not clear how dangerous that will be for you, but it can be a serious problem for astronauts in space. When solar storms mess with the magnetic field, this can affect the migrations of some animals, such as sea turtles, whales, and birds. Since things in the animal kingdom mostly work in the natural order, who knows how these animals go through or even survive such changes? And when the sun is at a maximum of its activity, satellites in space are in trouble too. We have more satellites in space than ever before. And when the upper atmosphere becomes denser because of all these changes, this can push satellites in different directions. They might crash into one another, or some can even fall back to Earth, which again is only cool in movies with superheroes who can relatively easily deal with this stuff. Hopefully, we'll avoid a massive solar storm like the Carrington event. The story was similar. In August 1859, astronomers across the globe watched how the number of sunspots was getting bigger and bigger. A man named Richard Carrington was among them. At the beginning of September, he was sketching the sunspots when, out of a sudden, he was blinded by a flash of light. It lasted around 5 minutes, but it was spectacular. He later described it as a white light flare. It was a very strong coronal mass ejection, CME, and in only 17.6 hours, this storm crossed the long way between the sun and our home planet, 90 million miles, and unleashed its force on us, even though this usually takes days. And when this storm started, telegraph machines across the world sparked. Operators got electric shocks, and paper even caught fire. People were really scared and confused because they had never seen such bright skies before. Some even thought it was the end of the world. The next day, telegraph workers still couldn't work properly because Earth's atmosphere was still charged. They even managed to send messages using the auroral current instead of regular electricity. But it brought something incredible, 2 stunning auroras in the sky. People in Hawaii and Cuba could see beautiful northern lights, while those as far north as Chile could see the southern lights. It's all slowly but steadily escalating. Take solar flares, for example. These are powerful bursts of energy from the sun. In 2022, there were 5 times more of these flares compared to the previous year. Plus, the strongest ones, X-class flares, have been getting stronger and more common than before, too. And this might be way more extreme than anyone thought. Plus, it's likely to start a little bit earlier than we predicted. Scientists first thought the peak would happen in 2025, but it seems it could even occur by the end of 2023. We can't completely protect ourselves if a solar storm hits us directly, but we can still do some things like ground planes, adjust the paths of satellites in space, and try to make sure vulnerable infrastructure stays safe. To do all this, we need better solar weather forecasts to help us get ready for the worst. All this might sound very bad at first, but don't worry, solar flares won't destroy our planet. They do send charged solar material toward us at pretty high speeds, but it's not like we're completely doomed if these things hit us. Our planet won't leave us unprotected. We still have the atmosphere and magnetic field that keep us relatively safe. Our thick atmosphere is like a shield that blocks radiation that might harm us. So these solar flares can mostly affect technology, but they won't destroy Earth. I guess we have our own superheroes after all. What do you know about the weird and wacky world of states of matter? Most of us know that matter can be solid, liquid, and gas. Some of us even know about a special fourth state called plasma. But what about the extraordinary states that behave in crazy ways like dancing and color changing? Forget what you thought you knew about solids, liquids, and gases because we're diving into the wild side of physics. Let's go. First, we have quark-gluon plasma. This state of matter looks like a hot and soupy mess. It's a bizarre state that existed just moments after the Big Bang, when the universe was incredibly hot and dense. You see, inside all the things around us, there are tiny particles called quarks, and as far as we know, they're the smallest particles of the universe. They're the building blocks of our world. Just like Lego bricks, they come in different types and can stick together to form bigger structures. We have up quarks, down quarks, strange quarks, charm quarks, top quarks, and bottom quarks. All of them are held together by some special forces, the gluons. They're like the super glue that keeps the quarks stuck together. They carry a special force called the strong nuclear force. They're also kind of like the messengers, passing messages between the quarks and keeping them connected. Now, how do we create a plasma out of them? Well, we need to heat things up, and we have to use some serious heat to create the quark-gluon plasma. It's like throwing your pizza into a scorching oven. When you crank up the heat, the cheese starts to melt, and it becomes all gooey and runny. In the same way, when we heat quarks and gluons up a lot, like in extreme conditions, they become energetic and start to break free. All this transforms matter into a hot, soupy mess. That's how scientists can recreate this special state in laboratories, by smashing together particles at high energies. But why do we even need to do that? Well, studying the quark-gluon plasma helps us understand how the universe evolved and what happened in its earliest moments. To understand the recipe of the entire pizza, we need to know all ingredients, right? Including the melted cheese. Next, we have a Bose-Einstein condensate. It's a pretty weird state of matter. Let's try to explain it like this. Imagine you have a group of friends at a party. Usually everyone dances and moves around freely, creating a lively and energetic atmosphere. But what if something strange happens? What if all your friends suddenly slow down and start moving together in perfect sync, almost like a slow-motion dance? Sounds like something out of a horror movie. But that's what happens in a Bose-Einstein condensate. It's a unique state of matter, and it occurs when certain particles called bosons get extremely cold. When this happens, all the bosons gather in the lowest energy state possible. And then, they form a cool club where everyone is doing the same thing. Okay, first we take some gas with low density and cool it down to super low temperatures, close to absolute zero. It's like the coldest temperature possible. Because it's so cold, everything stops moving, including particles. That's because atoms and molecules have no energy left to move. This temperature isn't physically possible as far as we know, but we can get super close to it at about minus 459 degrees Fahrenheit. Scientists use lasers and special equipment to reach that state. But when it happens in a Bose-Einstein condensate, the bosons don't just become still like statues. Instead, they gather in the lowest possible energy state and kind of form a single entity. They start to behave collectively, as if they're part of one big superatom. Their motion becomes highly coordinated and synchronized. It's like the collective mind from Rick and Morty. Studying Bose-Einstein condensates helps scientists understand the strange and quantum nature of matter. It helps us to unlock the secrets of a hidden realm where the rules of the ordinary world no longer apply. Next, let's talk a bit more about quarks. These guys are so special that they get one more state of matter to themselves. This one is called QCD matter, or quantum chromodynamic matter. It's a fancy name for the theory that describes how quarks and the strong force interact. Remember how we were talking about Lego blocks? In the normal world, each block has its own color, shape, and size. But what if you could play with a special kind of Lego where the blocks change their colors, shapes, and sizes as you stack them together? That's a bit like what happens in QCD matter. Normally, quarks stick together tightly inside particles like protons and neutrons. It's like they're holding hands and can't move around much. But when things get super hot or under a lot of pressure, something interesting happens. The force that holds the quarks together, called the strong force, becomes weaker. It's like their grip loosens, and suddenly the quarks can move around more freely. This is when QCD matter appears. When the strong force weakens, the quarks start acting like they're in a fun playground. They can zoom around and interact with each other in exciting new ways, and even change their colors. It's like the building blocks coming to life and having a blast. Scientists study QCD matter in particle accelerators like the Large Hadron Collider. They smash particles together at incredible speeds and energies. They almost create mini early universes and the hearts of neutron stars in their labs. They study QCD matter to understand how quarks behave and how the strong force works in extreme conditions. This way, we can learn more about the fundamental nature of matter and the forces that hold it together. In other words, it helps us to understand how our universe is built. And finally, we get to the last weird state of matter called neutronium. Imagine you have a bunch of balls. Some are red and some are blue. They're all bouncing around, constantly colliding with each other. Now let's take away all the red balls and keep only the blue ones. That's a bit like neutronium. Neutrons are tiny particles that hang out in the nucleus of an atom, along with protons, like a cozy group of friends. They're like the chill buddies of the atomic world. They're neutral, meaning they don't have any charge, hence the name. They play an important role in holding the nucleus together and determining the properties of different atoms. Neutronium is a substance made up mostly of neutrons. And in this weird substance, neutrons all by themselves, without any protons. It's like a neutron-only party. So what happens when we leave them alone? Well, neutronium is incredibly dense. It's like packing a huge number of blue balls into a small space. In fact, it's so dense that a teaspoon of it would weigh as much as a mountain. Pretty crazy, isn't it? Neutronium also has another quirky feature. It's super strong. If you tried to squeeze this substance, it would resist and push back against you with a force called neutron degeneracy pressure. It's like the blue balls in our analogy being so tightly packed that they don't want to be squished any further. Scientists think that neutronium might exist in the cores of certain extremely dense objects, like neutron stars. These are celestial objects formed when massive stars come to the end of their lives and collapse under their own gravity. When this happens, particles find themselves in some intense pressure and extreme conditions. And this is how matter can transform into this extraordinary substance. Neutronium challenges our understanding of matter and continues to intrigue scientists, exploring the mysteries of the universe. So, from the mesmerizing dance of particles in a quark gluon plasma to the mind-bending behavior of atoms in a Bose-Einstein condensate, these strange states of matter have shown us that matter is full of surprises. Remember, the universe is a vast and mysterious place, and our exploration of these weird states is just the beginning. So, keep your curiosity alive and your mind open to the wonders of our world.